Hello, hello. Welcome back to, maybe welcome back. This is the third video for Unit 1 out of 4, Real Number System. The third lesson in Unit 1 is all about the real number system. So we're at 1.3, the real number system. All right. It'd be helpful to have a highlighter or a different colored pencil or pen or something for some of this. But let's kind of get down to some definitions for real numbers first. So all numbers that can be found on a number line are real numbers. Okay, real numbers can be very big numbers, 17,576,321, or super small numbers like 0.000007. Okay, they can be positive or negative. They can be in fraction form, and they can be in decimal form, etc. Okay, these are all real numbers. All right, so we can see that what we've got is a rational section and an irrational section. But what you need to understand is both of these sections are real numbers. So there's kind of like this big square, like this. Okay, and the real number system includes all these numbers. Then within that system, there are two different subsections. So if you didn't get one of these yet, make sure you grab one from me because this really helps explain it. So you can see that the real number system is this big bucket down at the bottom. Irrational numbers get put in it, natural, whole, integers, and rational numbers all get put in it. They all get put into this big bucket. But then once they're put into this big bucket, they separate themselves within rational and irrational. And then even rational numbers separate themselves between integers, wholes, and naturals. Okay? So if you didn't get one of these, this really helps kind of clear it up. So make sure you grab one from me. All right, so we're going to kind of start from the smallest and work out. So let's start with natural numbers first. So natural numbers are numbers from 1 and up. So these are also known as counting numbers. Okay, so now think about this. When I start counting, I've got these pins right here, right? When I start counting these pins, I don't start at 0. I go 1, 2, 3. I don't go 0, 1, 2, 3. Okay, so that's why counting numbers don't include 0. So this one, for example, 1, 2, 3, 4, all the way up to in the positive direction to infinity. Okay, but positives only. All right, so now we make that section a little bit bigger and we call them whole numbers. So whole numbers are no fractions or decimals, and they cannot be negative. So really, the only difference between whole numbers and natural numbers is that whole numbers now gets a 0. Okay, positives, no fractions. Ooh, sorry. Goodness, I was grabbing my water and it bumped my screen here. Sorry. Okay, so between natural and whole numbers, the only difference is a 0. Okay, now let's go with the next bigger one. So integers now is all of these whole numbers and natural numbers, obviously, and their negative counterparts. So again, we're still not at fractions or decimals, but now what we've got is -3 and all those negatives behind it. -2, -1, 0, 1, 2, 3, and all the way in both directions. But just positive or just whole numbers, okay? No 1.5, nothing like that. Just those whole numbers in positive and negative directions, including 0. Okay, so that's what we call integers. Now, rational numbers, all of these are rational numbers, and then we include a few more different things. So any number that can be written as a fraction or a decimal, but there's a quick little thing here when we're talking about decimals. This decimal cannot be a non-terminating, non-repeating decimal. So it can either be one that goes on forever and ever, but it has a pattern to it. So like, for example, 1/3, which can be written as 0.33333, and it just keeps going, right? That's a rational number because it's got a pattern to it. Even though the decimal keeps going, it has a pattern to it. Okay, or it can be something like 1/4 which is written as 0.25 because that decimal terminates. Okay? So as long as it either terminates or it has a pattern to it, it can be rational. Now, other numbers would be like -7, because -7 can be written as a fraction by putting a 1 under it. Okay? Or even 0.25. Oh, that's not what I meant. 0.5, because that is also 1/2. Okay, so any of these numbers are good examples because they can all be put into a fraction in some way. Okay, now let's talk about irrational numbers. Now, irrational numbers is any number that cannot be written as a fraction. Now, it can't be written as a fraction because the decimal form goes on forever without repeating. Okay. There's two main examples for irrational numbers. The first one is pi, which we all know is 3.14 da 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 da, and it goes on forever and it never repeats itself. Okay, so pi is a great example of an irrational number. The other great examples are non-perfect squares. So let's say the square root of 3. The square root of 3 is a non-perfect square because what I get is 1.732050, and it just keeps going. And notice how there's no pattern here. Nothing repeats, okay? So non-perfect squares are great examples of irrational numbers. So if I don't know, let's say I ask you guys, is the square root of 97 rational or irrational? If you put it into your calculator and you get anything other than a whole number, the answer is it's irrational. So notice how I got that same thing because basically it's in its simplest form. If I change it to a decimal, you'll see that it goes on forever with no pattern. That makes it irrational. Now, if I asked you what's the square root of 144, I get just 12, which makes it rational. Okay? Okay, so all of these numbers are real numbers, and within the real number systems, we have rational numbers and irrational numbers, and within rational, we have these other subcategories. Okay? Perfect. All right, so with your partners if you were in class, but if you weren't in class, you're going to need to do this one on your own. So basically what you're doing is you're just circling the classifications of the given number and make sure that there could be more than one. So let's do one first. I'll do one with you for really quick. So let's do 17. So 17, we know it's a real number because every number is a real number. So you should always circle real number. Okay, I know that 17 is a natural number because it's one of those numbers I use for counting. 13, 14, 15, 16, 17, right? I know it's a whole number because basically whole numbers are the same as natural numbers except they add 0, and 17 is included in that. I know it's an integer because it says an integer is a whole number and it's negative. And so since this is a whole number, it's an integer. And it's rational because it can be made into a fraction, right? All I have to do is add a 1 under it and make it into a fraction. So it's all of these except irrational. And the reason why it's not irrational is because if it's rational, it can't be irrational. It's got to be one or the other of these ones. Okay, so if I circle this one, it's none of these. If I circle this one, it's definitely not that one, and then it could be part or all of these. Hopefully that makes sense. And then make sure you do down here at the bottom, these quick little 3s, it just kind of is asking you to use your brain a little and think back to number lines. Make sure I see this so I can mark you off for the notes if you were absent that day. And yeah, thanks guys. Have a great day.